PFC regulation. I'm going to get to the scary slide of common uses. Then we're going to talk about some regulatory information, treatment options, and then PFCs in Florida. Background health and environmental concerns. PFCs are a diverse group of chemicals, and they're used for their capacity to retard fire, repel oil stains in water. They're an environmentally persistent group of organofluorine chemicals. They're extremely stable, that's because of the structure which they're put together, and persistent due to the chemical construct of the PFC compound. And that's that carbon-fluorine connection, which is, according to David Wales, the second strongest organic bond. I have no way of verifying that, but I took his word for it. PFCs have served many purposes, both in industry and consumer product applications. There are some new health advisory levels for both PFOA and PFOS. Different types of scientists may refer to the same class of chemicals by different names, and PFCs are no exception. This is a list of some of the commonly used terms for PFCs you might come across, and they include, I'm not going to read all of those. I will tell you something you may be able to relate to a little closer. Everybody knows what dioxin is, right? Yeah. You know, who was the big bad boogeyman? Well, dioxin is actually just the name of a family of dioxin. There's only one real bad boy, and that's the 2378. I can't remember it all. P-dioxin, dibenzo P-dioxin. That's the bad one. There are about 13 or 14 more dioxins that are out there that are not bad at all. I mean, they're as benign as they can be. But just like PFCs, some are pretty benign, some are not so. EPA studied PFCs due to concerns of high potential for exposure to humans, persistence in the environment, and that's because of that structure of that molecule. It's very, very resilient. The observed toxicity in animal models, and there's insufficient information to properly assess all human health risk at this point. PFCs are found in water, soil, food, air, and human blood. Very soluble in aquatic systems. Low levels found in humans throughout the U.S. population. The half-life of PFCs in the human body can range from 4 months to over 9 years. Basically, after 9 years, you got half of what you had before. It'll take another 9 years to remove another quarter of what you're starting with. It bioaccumulates, and they have known negative effects in laboratory animals, such as abnormal endocrine activity, tumors, organ damage, immune system dysfunction, and reproductive and development problems. PFC can enter groundwater or surface water through water effluent, application of biosolids, landfill leachate, and stormwater runoff. Did I miss an avenue? Based on persistence or composition, PFCs are difficult to remove. The highest point source concentration of PFCs in source waters are associated with the use of firefighting foams and other industrial discharges. This should make you feel very comfortable. Common uses: fabric, carpet stains, and water repellents, aqueous firefighting foams, and cookware coatings. I think the 3 top are bolded because those are the 3 predominant pathways. Waxes and polishes, leather treatment, oil and mining surfactants, pesticides, rubber products, tires, sorry ladies, cosmetic, dental floss. Is anybody feeling uncomfortable at this point? Treated upholstery, metal plating, electronic and computers, waterproof fabrics, thread sealant tape, stone tile, and wood sealants. Treated apparel, food containers, as an example, popcorn bags. Soap and cleaning products, paint and coatings, photographic products, and hydraulic fluids. Again, did I miss anything? Regulatory information. In 2009, EPA had set a provisional health effect advisory levels of 0.4 microgram per liter for OA and 0.02 microgram per liter for OS. In May of 2016, EPA issued a combined health advisory level, or a HAL, of 0.071 microgram per liter for total OAOS. The HAL provides levels of OAOS in drinking water at or below which advised health effects are not anticipated to occur over a lifetime of exposure. A HAL does not establish a regulatory MCL. It does provide guidance to assist state, federal, and local officials in evaluating drinking water quality. EPA's 2010-2015 PFOA stewardship program coordinated emissions with emission reductions of PFCs with 8 large chemical companies. Those were the primary manufacturers of these. And the aim was to reduce about 95% of the OA and long chain PFCs by 2010. I'm not sure if that was fully accomplished, and completely eliminated emissions of long chain PFCs by the end of 2015. And again, I'm not sure if that was accomplished yet or not, but I'm going to give you some additional information where you can keep track of this if you need. Treatment option for the removals of PFCs. Removal efficiency of treatment techniques for PFCs from source waters depends on the influent water characteristics, including the total PFC concentration and the treatment method utilized. Conventional treatment methods have proven to be unsuccessful for PFC removal. There are some advanced treatment techniques that can reduce up to 90% or higher. They include active carbon filtration. It is highly effective treatment to remove greater than 90% of both OA and OS species. Anion exchange shown to remove up to 90% of some PFCs. High pressure membrane filtration, of course we're talking about RO and nanofiltration. It can remove up to 90%. Advanced oxidation can remove 10 to 50%. I'm not sure why anyone would want to choose that option, but there it is. And again, dissolved air flotation, up to 50% removal of some PFCs. In Florida, nationwide, EPA's unregulated contaminant monitoring rule number 3, or the UMCR3, required all large PWSs and selected 800 small PWSs to monitor for PFCs. Anybody here involved in that program? We have one. Approximately 250 PWSs in Florida monitored under UMCR3 or UCMR3. The OAS was detected in only 12 PWSs in Florida. I guess that's good news. Only 3 of the PWSs in Florida had the OAS levels above the new HAL. The 3 PWSs have correction action underway. Florida is reviewing existing data and scientific studies. I can tell you one of the first things that we did when we found out what the measure and level of concern was is I called the State Fire Department, the State Fire Marshal's office and said, can you give me a listing of all your training facilities where you may or may not have used firefighting foams? And then once we got that information, then we were able to look at some of the utilities that were within a delineated area close to those and started looking on ourselves. The federal government, through the military, is also looking at their air bases where they use firefighting foams also. So there's a lot of study going on here right now. Looking at both point and non-point sources to identify some of those, as I just indicated. And we are collaborating with states and the EPA. And we're beginning to establish that baseline monitoring database that we're going to need to continue moving forward. This is that website if you want some more up-to-date or continued information on what's going on with these 2 compounds. This is where their new health advisory is located and some additional information. And that's the end of that presentation. And if you have some questions, I'll be glad to answer for you the best I possibly can.
Got one back here.
I've got 2 back there. Yes, sir.
What was the acronym
How? Health effect language. Health effect language. Yes, sir. Did you have a question? Does that make you feel good? Did that presentation give you a warm fuzz? I had to read this thing and put it together. And it gave me a bad feeling. I didn't like it at all. I like this guy though.
Thanks, Ken. Actually, the 3 systems in Florida were able to shut down their wells that were affected without any problems for the system. One of them was a well at their location at a fire station, where the fire station practiced with the foam. So they would have known there was a problem, but they were able to shut that well down.